Okay, so today we will be starting a new chapter, chapter 7.1, and it deals with systems, both linear and nonlinear, as well as inequalities and stuff. So today, 7.1 notes deals with one of the many ways of solving a system, right, and that's by substitution. And now, before we get started, it's kind of a good idea just to kind of refresh ourselves in knowing what a solution to a system. A system is a series of two equations and two unknowns. Now, a system can be more than two equations and have more than two unknowns, and we'll get to those examples later in this chapter, right? But by and large, the majority of your systems will be two equations with two unknowns, x and y. Okay, so what is a solution? And the best way to do this is to look at it graphically. We're not going to solve these graphically. I mean, you can do that, and if you don't graph it by hand like accurately, then your answer is going to be a little off. You can do this in the graphing calculator, and I find it very useful to know what the solution, a solution or no solution or infinitely many solutions looks like graphically. That's what the space above on the top part of your notes is for, so we can just kind of get a good picture of what it looks like, right? What each of these types of solutions look like, and so then when you're working with these things, you can kind of keep these in mind as you're solving these, right? So say you have a graph. Okay, here's your x and y. Again, I'll change the different colors, right? So say one equation's doing this, and one equation's doing this, right? So your solution is where these two graphs cross, right? So this would be one solution, right? So there's a solution, it crosses once, so there's one solution. There's another type, right? So say you have a blue line that does this, and then your green line does, oops, that's not green. There we go. Your green line does that, right? So those are what are considered parallel lines, right? So parallel lines never cross. So this would be called no solution, right? And then the third type of solution that you get a lot of times, especially with linear, is what's called infinitely many, right? So say you have a blue line, and then say you have a green line, and you have a green line, right? So this blue line and green line are on top of each other, right? It's the same line. So this is what's called considered infinitely many. Okay, so these are the three types of solutions that you could get when solving a system. By and large, the majority of yours, actually all of the problems that you'll do today, you'll get one solution, right? You should get one solution. If you didn't, then you made a mistake. Okay, so here are some different problems, right? And the skill in solving systems, once we've kind of gone through all these, is determining which method would be the easiest, right? Sometimes that might work into, or sometimes that might fall into which method you find the easiest to do, right? A lot of times I like substitution just because I love algebra, right? So I'll tend towards this method over some of the other methods that may be a little bit faster, just because I know I can turn out an answer real quick. That's just me. So you need to find what works for you. Once we've gone through all these, and we'll practice solving individually, determining which method would be the best and solving those at a later point. So, but today we're just working on substitution, right? So our first equation is x plus y equals 4 and y equals 3x. So in the second equation, you're already told what y equals. It equals an expression, 3x, okay? So what you're going to do with this expression is you're going to take it and you're going to substitute or replace the y in the first equation with 3x. Right? And the reason you're doing this is because in the top equation you can't solve for one or the other. I mean, you can, but you can't get an answer, you can't get a number, because you have two variables, right? An x and a y, right? And there's no way to get rid of one or the other. Okay? But if I substitute 3x in, I get x plus 3x equals 4. Right? Now I have common variables, right? I have both x's in that equation. Now I can add those, right? So 1x plus 3x is 4x equals 4. If I do some simple algebra, I get x equals 1. Okay, now I take this answer, x equals 1, okay, and I can plug it into either equation, right? I can plug it into the top, right? So I can get 1 plus y equals 4. Do some simple algebra, and I get y equals 3. I could do that, or you could plug it into the bottom, right? So you get y equals 3 times 1. 3 times 1 is 3, right? The second one was probably a little bit easier. So, you know, it's just the skill of picking which equation to plug in that, you know, it takes some practice, some time to see which one would be the easiest to do, right? But as you can see, you get the same answer. Okay. Now this one, you have x equals 4y minus 2 and x equals 6y plus 8. Right. Now they both equal x. If you look at this, you know, a good way to know substitution. Right. In the first one, you're already told what one of the variables is, so that's easy. I can plug it in and go. This one, if you're given both equations equal a certain variable, like x or y, in this case it's x, right, you can set them both equal to each other. So here's what I mean by that. So 4y minus 2 equals 6y plus 8. Okay, now the x's are gone. Now it just becomes what's called a variables on both sides type of problem, right? So now I just got to combine. There's lots of different ways of solving this. I'll move to 4y. Right, so I get negative 2 equals 2y plus 8. Subtract 8. I get negative 10 equals 2y. Divide by 2, so I get y equals negative 5. Okay, so just like the last example, I can take this negative 5 and plug it into, this value for y, and plug it into either equation and get x. There's not one that may be a little bit easier, right? So you just kind of pick, I'll just pick the top one, right? So 4 times negative 5 minus 2, so that's negative 20 minus 2, x equals, so x equals negative 22, right? And if you, something I forgot to mention, we're getting two answers, right? We're getting an x value and a y value, right? And how your books and how a lot of tests will write it as this as an ordered pair, right? So this would be negative 22, negative 5. So what that means is at negative 22, negative 5, these two lines right here, this equation and this equation, they cross at this point, right? At x plus y equals 4 and y equals 3x, right? At the point 1, 3, those two lines will cross, right? So if you go back to the graph, at those 2 points, the lines will cross, right? Okay, so now the last one, right, is what a lot of times your systems will look like, right? So x plus 2y equals 0, and x minus 3y equals 0, right? So you're not told what one of the variables equals, or you know that they both equal the same thing. So now you have to pick one of the equations, solve for one of the variables, and take what you solved and plug it in, right? So this is the really heavy algebra part of substitution, okay? And this is where a lot of kids and students can make mistakes. And this just takes a lot of practice to get really good at it. Okay. Now, if looking at this system, right, if I solve for either of the variables in the top equation, 5x plus 2y equals 0, if I solve for that, I get fractions, okay, which isn't bad, but, you know, a lot of students tend to not like fractions, so I'll try to stay away from that. So I'm going to look at the bottom equation, x minus 3y equals 0. Now, I could solve for either x or y, but one variable might be a little bit easier to solve for than the other. And if you take a look at it, solving for x will be a lot easier because there's no coefficient in front of x. It's an understood 1, right? So all we'd have to get rid of is this negative 3y. And if we can move it over, then we have what x is, and we can plug it in, right? So taking this, so if I add 3y to both sides, I get x equals 3y, right? Now this is exactly like the first example, right? I have an equation, 5x plus 2y equals 0, and I have another equation which I've kind of modified a little bit. It's x equals 3y. Now I'm going to take this 3y, and everywhere where I see an x in the first equation, so right here, I'm going to substitute 3y. Okay, so it'll look like this. 5 times 3y plus 2y equals 0. Okay, now you multiply. So that's 15y plus 2y equals 0. So adding, you combine those together, you get 17y equals 0. Divide by 17, and you get y equals 0. That looks like numbers. Y equals 0. Okay? Now, if y equals 0, then you can take this and you can plug it into any equation. You can plug it into this one, right? You can plug it into this one. Or you can plug it into this one that we've kind of modified, which would be probably the easiest, right? So you have x equals 3 times y being 0, right? 3 times 0 is 0. So these two lines, 5x plus 2y equals 0 and x minus 3y, they cross the origin, which is 0, 0. Okay? Hopefully this helps. If you have any questions, please email me or comment. Thanks.